In this video, we will look at how to solve a uniform motion problem using a rational equation. Professor Francisco traveled 240 miles at a constant speed. If the average speed had been increased by 20 miles per hour, the trip would have taken 2 hours less. We need to find the professor's average speed, what it actually was. Okay, so let's look at some of the information in the problem. We know that he traveled 240 miles at a constant speed. So that was what he actually traveled at. And then hypothetically, if he had increased his speed by 20 miles per hour, he could have decreased the time of his trip by 2 hours because the trip would have taken 2 hours less. Okay, so let's set up our table here so we can organize the information. He actually only took one trip, but hypothetically, he could have taken a second trip at a faster speed. So let's organize the information in our table. We'll say there's trip 1 and trip 2. So trip 1 was the actual speed of 240 miles. Trip 2 would be the hypothetical speed if he had increased his speed by 20 miles per hour. Now, across the three columns, we will have the distance, the rate, and the time. And let's just remind ourselves our units are miles, miles per hour, and hours for the time. Okay, we know that his trip was 240 miles, so no matter what speed he traveled at, his distance would be the same, 240 miles. Let's let the rate of his actual trip, which is trip 1, just be r. And then if he increased his speed by 20 miles per hour, the rate of trip 2 would be r plus 20. So now what we need to do is we need to write a ratio using the distance and the rate to represent the time for each trip. And if we go back and read the problem, we know that when we have these ratios, we know that the ratio for the time of trip 2 is actually going to be 2 hours less than the ratio for the time for trip 1. So let's set up our time ratios. So for trip 1, the time is the ratio distance divided by rate. So 240 divided by r. And then for trip 2, our distance is 240, but this time we're dividing it by r plus 20 for the rate. Now, it might help to write the equation out in words using the information regarding the fact that if he took trip 2, it would have taken him 2 hours less than trip 1. So what that means is that the time for trip 2 is 2 hours less than the time for trip 1. So now what we can do is we can insert our time ratios and our equal sign, and then we will have our rational equation. So the time for trip 2 is the ratio 240 over r plus 20. Now that is, which means that's where our equal signs go, that is 2 hours less than the time for trip 1. So we're first going to write our ratio for the time for trip 1, and then from that we are going to subtract 2. So that shows us that it's 2 hours less than the time for trip 1. Now we have a rational equation to solve, so the first thing we're going to do is find our LCD, and that is going to be r times the quantity r plus 20. So then we will multiply both sides of this equation by the LCD, and remember you can put the LCD over 1 if that helps you. All right, so on the left-hand side, we're going to distribute our LCD. So we're going to have our numerator 240 multiplied by the factor r of the LCD, because the factor r plus 20 will divide out. On the other side of our equal sign, we're going to distribute our LCD. So we're going to start with 240 times the factor r plus 20 because the factor r will divide out. But then we're going to have minus 2 times r plus 20. So when we distribute the LCD to the constant minus 2, nothing divides out. So we contain the whole LCD is going to get multiplied by negative 2. All right. Now we get to simplify. This is the fun part, okay? So let's simplify our equation. So we have 240r, and we're going to distribute on the other side of the equal sign. That's going to equal 240r plus 4,800. Now, for this next part, we're actually thinking of it as distributing negative 2r to the binomial r plus 20. So that will give us minus 2r squared minus 40r. So as soon as we see that we have an exponent of 2, we know that our goal is to set the equation equal to 0 and get it into standard form. So I am going to show you what it looks like once we set it equal to 0. So we will have 0 equals negative 2r squared minus 40r plus 4,800. Hopefully you notice that the r term 240r on each side will cancel out. So now we notice we have a quadratic equation in standard form. So we first look for a GCF. Our GCF is negative 2. So if I factor out negative 2, I'm left with the trinomial r squared plus 20r minus 2,400. So at this point in the video, you can pause it and you can continue to factor it on your own and solve it. Or if you want to keep watching, I will go on to the next slide where we will factor the trinomial r squared plus 20r minus 2,400. We can ignore the GCF of negative 2 this time because it won't produce a solution. So we're going to factor r squared plus 20r minus 2,400. So we have r squared plus 20r minus 2,400. So we want numbers that multiply to negative 2,400 that add up to positive 20. So that will be r plus 60 and r minus 40. Now remember, these expressions are set equal to 0. So now if we use our zero product property, we will get two solutions. So we get r plus 60 equals 0, or we get r minus 40 equals 0. So for the first solution, we're going to get r equals negative 60. And for the second solution, we're going to get r equals positive 40. Now remember, r stands for the professor's actual speed. So having a speed of negative 60, that doesn't really make sense. We joked in class that would mean he was driving backwards, but of course we know that is not true. So his speed would not be negative 60 miles per hour. His speed would be 40 miles per hour. So we can write out a nice sentence to explain that. So his speed was 40 miles per hour. Or if you're working on the assignment online and you want to go back to that original slide, we can see that his speed was actually 40 miles per hour. So hopefully this video helped you understand how to set up the rational equation. And let me know if you have any other questions.